Okay, so now that we've defined kinetic energy, we've defined potential energy, we're ready now to explore something very important called the mechanical energy conservation theorem. And what the theorem states that if the work done is simply due to the conservative forces, that means there are no non-conservative forces. No non-conservative forces. Okay? If a system evolves in time such that the work done is only due to conservative forces, then the then the mechanical energy of the system remains constant. Now, let us define mechanical energy, and mechanical energy is nothing but Ke plus Pe. So what this statement says is that if the work is simply the work done by conservative forces, then mechanical energy initial is equal to mechanical energy final. It does not change. Okay, so let's go ahead and prove this theorem. It's a very useful theorem, and then we'll apply this theorem. Okay, so now let's begin with the assumption that W is simply equal to WC, which is that the net work done is simply equal to the work done by the conservative forces. Now we know from the work kinetic energy theorem that the net work done is simply equal to the change in the kinetic energy. And we also know from the definition of the potential energy is that it is equal to the change in the potential energy is negative of the work done by conservative forces, and so we can say that the work done by conservative forces is equal to negative of the change in the potential energy. Alright, so from here on the calculation is very simple. Delta Ke is Kef minus Kei, and delta Pe similarly is Pef minus Pei. So now I can distribute the negative sign and write this as Kf minus Kei equals negative Pef plus Pei. And now all we need to do is move the final terms and the initial terms together. So I'm going to move the final Pef to the left. So I get Kef plus Pef is equal to Kei plus Pei. So the theorem is very simple. It states that if the work done on a system is simply due to conservative forces, then the mechanical energy of the system remains constant. So this is what we have. MEF is equal to MEI. So again, under the condition that W is simply equal to WC, no non-conservative forces, which means no friction, no push, pull, and all that stuff. Okay, so that's it for this one.